Hi students, today we will discuss one problem on diagonalization. The heading is diagonalization of a matrix. So the problem is diagonalize the matrix. The given matrix is A is equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. So to solve this problem we have 5 steps and this is a very lengthiest problem, so I have divided it into 5 steps. So let's see what are the step numbers. Step number 1 is we have to solve the characteristic equation determinant of A minus lambda I is equal to 0. So if we found this characteristic equation using this A minus lambda I, we will get the values and those values are called as eigenvalues. This concept I have dealt with the previous video of finding out the eigenvalues problem. You just refer the eigenvalue problem for that in the same channel. Step 2, find eigenvectors corresponding to eigenvalues. So once we got the eigenvalues, we will find the eigenvectors. For that we will use the same thing, that is A minus lambda I multiplied by x is equal to 0. We will take it, we will see that later. Step number 3 is find the modal matrix P. We will also see what is this modal matrix. Step number 4 is find the inverse of modal matrix P, which we got in the step number 3. P inverse is equal to P transpose divided by determinant of P. Sometimes we will call this numerator also as adjoint of P. Step number 5 is solve diagonalization. D is equal to P inverse. So we have to find the inverse of this modal matrix, which we got at step number 4. A is nothing but the given matrix, and P is nothing but modal matrix, which you got in the step number 3. So we'll solve one by one now. So with the help of this already known things, finding the eigenvalues, we'll start solving the problem. So step number 1, characteristic equation A minus lambda I is equal to 0. So what is A minus lambda I? A is the given matrix right here, minus lambda I. I ends here, I comes the 3 cross 3 matrix because the given matrix is 3 cross 3 matrix A. So that's why we have to choose identity matrix which are diagonal elements 1 with 3 cross 3, 3 rows 3 columns. So here next simple subtraction, matrix subtraction, you will get like this. Then after that, take the determinant of this determinant symbol and make it equal to 0 because of characteristic equation. So simple determinant format, start taking 6 minus lambda, 3 minus lambda into 3 minus lambda, minus into minus plus 1. So here you will get minus, why it is plus is minus into minus becomes plus 2. So if I ignore this, minus 2 into 3 minus lambda, I will get minus 6 plus 2 lambda followed by minus of 2 minus 1. So that is plus 2. So similarly it is carrying up to third bit. So now I will not simplify all these things. I have just written this after simplification. It's just mathematical simplification, and you will term the cubic term, square term, and single term and constant. So find out this and you will get this cubic equation. So if I use a calculator and I solve this, you will get 3 values. First value is 2, second value is 2, and third value is 8. So order may be different, whatever may be, order is immaterial here. So observe this carefully. This you got 2 and this also you got 2. So we will call this as repeated eigenvalues. When the repetitive eigenvalues come, the next step is going to be a little bit different, that is finding out the eigenvectors. So in this step number 1, what we found the eigenvalues, not just eigenvalues, it is repetitive eigenvalues. So here we will see the step number 2. We have to find the eigenvectors for what? The eigenvalues 2, 2 and 8, which you got in the previous step. Next, for this eigenvectors, as I told, we have to use A minus lambda I multiplied by x vector. It is a column vector, column matrix. So I will consider first value as 8, lambda 3, lambda 1, lambda 2, lambda 3, just I have written for my easiest way of writing. So you just number however you want. So I have taken lambda 3 is equal to 8. So here this is what the determinant which we got in the previous step. So here the same thing, so the same here I have written. So in this A minus lambda I followed by x, why I have written x as 3 cross 1 and obviously 0 is 3 cross 1. Just look at here, it is 3 cross 3 matrix. This 3 and this 3 should match, that's why 3 will come here. And here if I take 1, as I told, it is a column matrix, so obviously column matrix means it is having only one column. That's why number is 1. So it is, you can just observe 3 and 3 both must be same, and this 3 cross 1 is exactly same as this 3 cross 1, which is a RHS. So now put lambda equal to 8 in the above equation. So if I put, I will get this one, same thing. Then from this I will take this minus 2 into x1 minus 2 into x2 and plus 2 into x3 is equal to what? 0. Second equation, minus 2 into x1 minus 5 into x2 minus 1 into x3 is equal to 0. So now by using these two equations, I will go for use cross multiplication by taking x1. So once I take the x1, I will leave this. I will cross multiply these two, x2 value and x1 coefficient. x2 coefficient is minus 2, x1 coefficient is minus 1. What is minus 2 into minus 1? It is plus 2. That is what I have written here. Then minus of 2 into minus 5. What is that? Minus 10. So already minus is there. Minus into minus is plus 10. Similarly, x2. Leave this. Multiply these two, minus into minus plus 2, and this 2 into 2 is minus 4, already minus is here, so it is going to be plus. Similarly do it for x3, leave this, minus 2 into minus 5, it is plus 10, minus 2 into minus 2, plus 4, but minus is here already, so it is going to be 4. So like this we have find out the ratios of x1, x2 and x3. So now you got denominator as 12, 6 and 6 here. So here, since it is common, I am going to divide it by 2. So 6 1s are 6 1s are 6 2s are. So you will get this. I'll substitute this is equal to 1 constant term k. So what is the value of x1? I can write it as 2 into k. What is the value of x2? I can write it as minus k. What is the value of x3? I can write it as k. So now, once I got this, so here, first eigenvector I will find by the letter x1 is equal to x1, x2, x3. What is the value of x1? 2k, x2 minus k, x3 plus k. So if you take k outside, you will get 2 minus 1, 1. So this 2 minus 1, 1 is going to called as first eigenvector, and that we got it for lambda is equal to what? 8. So similarly, we will see when the lambda is going to be for 2. So this is the second case when lambda 1 and lambda 2 both are same in this case. So we will find second eigenvector as well as third eigenvector. Second eigenvector is represented by x2, third eigenvector is represented by x3. So substitute lambda is equal to 2 in the previous format. Here take this and substitute lambda is equal to 2. So you will get this matrix, same x vector column matrix. So here I will take the first equation and second equation as like the before, but observe here I can't use this ratio like this, x1 and minus 2 into, so you will get denominator. You can observe the denominator here, so you are going to get it as 0. So I can't use this. So what you can do is I will use the equation 1 and 4x1 minus 2x2 plus 2x3. So here, since the two repeated eigenvectors are there, so here I am going to have assume x1 is equal to 0. So 2 times you have to assume, 1 time you will assume x1 is equal to 0 in this. So if you assume x1 is equal to 0, you will get 2x2 is equal to minus 2x2 is equal to minus 2x3. Cancel all the terms, you will get x2 equal to x3. So x2 by x3, if I write it, what is the value? Will get 1. So what is the value of x1? 0. What is the value of x2 and x3? Both are same. So second eigenvector is x2 is equal to 0 1 1, and we got this for lambda is equal to 2. Similarly, the third eigenvector x3 is calculated by putting x2 is equal to 0 in this. If I substitute x2 equal to 0, what you will get? 4x2 is plus 2x3 is equal to 0. So after simplification, you will get x1 by x3 is equal to minus 1 by 2. So what is the value of x1? Minus 1. What is the value of x2? 0. What is the value of x3? 2. So this is the third eigenvector for lambda is equal to 2. Since it is 2 are repeated values, we are going to assume here one value and we will find the other two values. So this is what the eigenvector calculation is. That is step number 2. So what is step number 3? Find modal matrix P. So writing the modal matrix P is very easy. P is equal to first column you have to write whatever may be the eigenvalue. Suppose eigenvalue for 8, what is the eigenvector you got? Write it. For eigenvalue 2, what is the eigenvector you got, write it. For eigenvalue 2, what is the eigenvector you got, write it. Just the collection of eigenvectors in column wise which we got in the step number 2 is called as modal matrix P. So once I got the modal matrix P, go for the step number 4, which is finding the inverse of this modal matrix P. P inverse is equal to Pt divided by P. So here denominator is very easy. I will calculate the denominator first. So it is determinant of P. So take this P and find the determinant. So I think you know determinant, how to find it. Take 2 and 1 into 2, 1 into 0, 0 and minus 1. So it's minus 1 into 2, 1 into 0. So at the end you will get determinant of P is equal to 6. But the very important thing is finding the numerator, that is adjoint of P or P transpose. How to calculate it? Finding the cofactor matrix of P and transpose becomes the adjoint P. So we have to find the cofactor matrix. How to find the cofactor matrix? Write in format C11, 1, 2, 1, 3. Once your first letter stands for row and the second letter stands for column. So we have to find these entries first. For that we have the formula, use Cij is equal to minus 1 raised to 1 plus j, determinant of Mij. So in the previous problem which I solved, in the determinants and the cofactors I have used the same formula. Here also I am using the same formula. For that you have to go through that video. C11 is equal to, what is R row 1 column 1, minus 1 raised to 1 plus 1, I1 J1, determinant of M11. How to find the, so here minus 1 raised to square, how to find the determinant of M11? So here you can observe it is 1 1. So excluding this column and this row, what are the entries? 1 0 1 2, right? That 1 0 1 2. So now you will get the determinant of this and at the end you will get 2. Similarly 1 2 minus 1 to 1 plus 2, determinant of M12. How to find M12? First row second column. First row second column. Ignore these all things. And what are the remaining things? Minus 1 0 1 2. So that's what I have written and I have found it. For more details about this finding out the minors and the cofactors, you refer my previous problem of minors and cofactors in the channel. So similarly we will find C13 as minus 2, C21, C22, C23, C31, C32, C33. All entries we will find by using the same formula. Just I have shown you the example 2. Based on that, find the remaining entries. Then after this we will just collect what are the things we found under cofactor matrix. Once I got the cofactor matrix, you have to take the inverse, you have to take the transpose of this. If you take the transpose of this, 2 2 2, row becomes column and column becomes rows. So at the end P inverse is equal to P transpose divided by determinant of P. P transpose is this one. What is the determinant of P which you got in the previous step? So that is 6. So this is what the inverse of the modal matrix P which you got. So next is step number 5, and which is the last step. So we will see that the last step is to solve diagonalization. D is equal to P inverse A into P. So here we know that the diagonal matrix includes diagonal eigenvalues. So D is equal to lambda 1, lambda 2, lambda 3. You can observe the diagonal entries. Those are going to be lambda 1, lambda 2, lambda 3 are eigenvalues. What are the eigenvalues which you got? 8, 2, 2. So as I told, the naming is immaterial. You can write however you want. So that is what the entries are. So here now take RHS. So P inverse A into P. I will take the RHS P inverse A into P. So I will write the inverse of the P which you got, inverse of the matrix which we got here. The same thing. What is A? A is a given matrix which is at the beginning they have given the A value matrix, that is P. P is modal matrix which is consisting of eigenvectors. So these three all we have to multiply and do the necessary matrix multiplication. So we will get this. So it is this value you are going to get when you take first row, first column. This you will get first row, second column. This you will get first row, third column. So first with respect to first is over. Similarly, you have to take the second row, first column, second column, third column. Third row, first column, second column, third column. So you will get this one. So these two multiplication we have done, and this we will write the modal matrix as it is. Once I got this, again the same procedure. First row, first column. 16 2s are 32, minus 8 minus 1 plus 8, 8 and 1 8. So first row first column first entry. Similarly first row second column. Similarly first row third column. So all the entries are going to be filled, matrix multiplication. So at the end you will end up with 48 0 0 0 12 0 0 0 12. So here denominator 1 by 6 is there. So if I divide it, you are going to get 8 2 2. It is exactly nothing but the diagonalization. So P inverse AP is equal to 8 2 2, which are the diagonal elements, also the eigenvalues, which is exactly equal to the D value which we have found here. So this is what we will call the diagonalizing the matrix. So it is looking like a little bit lengthier one, but it is going to be a bigger problem. Definitely it is going to be asked for 10 marks in the main examination of fourth semester students of ECE under engineering statistics and linear algebra subject. So briefly, step 1, solving the characteristic equation and finding the eigenvalues. Step 2, finding the eigenvectors corresponding to eigenvalues. Step 3, finding the modal matrix P. Step 4, finding the inverse of modal matrix. And step 5 is solving for D is equal to P inverse A into P. So this is what the problem is all about. So I conclude this problem at this stage. Thank you for listening.